Welcome to another video by AskMath.com. Let's read the directions to this problem. How many solutions does the system of equations have? Given y equals negative 2x plus 5 and negative 15 plus 6x equals negative 3y. I'm actually just going to switch these around here. Okay. So remember, let's take a look and see what we're being asked by the directions. A system of equations just means that you have two or more equations, which is what we have here. Anytime you have an equation that has two variables, like an x and a y, and there's only math like addition, subtraction, multiplication, and division, for example, no exponents. If you were to graph an equation like that, it would make a straight line on a graph. And we have two such equations, so that means that we would have two straight lines on a graph. And if we graph two straight lines, there are only three ways that that can turn out. You could graph two straight lines that are parallel, and those will never intersect each other. And that would have zero solutions. You could draw two straight lines that do intersect each other, and because they're straight lines, they'll never turn and intersect each other again, so they just intersect each other at just one point. And so the answer to this question, how many solutions, would be one. This is the solution. The solution would have an x and a y coordinate, but we're not being asked what the x and y values of those coordinates are. We're just being asked how many points, how many solutions does this system have. It just has that one point, that one solution. And the third possibility is that you could draw one line on a graph, and then you could graph another line right on top of it, and that would have infinite solutions. Because every point on both lines line up with each other all the way, infinity in each direction. So there's only three possible answers to this question. Now there are, to find the answer to this question, what you need to do is try to solve the system. So you have to assume that there's one solution, try to find what it is, and then see what happens. So there's three methods of doing that. One is graphing, and graphing works well if the equations are relatively small numbers. You have, graph paper handy, there aren't any decimals or fractions. And these numbers, they get a little bit big, like negative 15. I don't really want to try to graph that. Substitution is another method that you can use. And that works best when a variable, like this y here, is all by itself on one side of the equal sign. So on the left side of that equal sign, it's just a y. So that's a good time to think about using substitution. The third method is combination, and combination works well when the variables in one equation line up with the same types of variables in the other equation vertically. So for example, here we've got this negative 2x, and below it is a positive 6x. But remember, before you line those up, you have to line up your equal signs. So if we shifted this whole equation to the right so that this equal sign lined up with that equal sign, that would put our x's over here and the 5 over here, and it would leave this negative 15 plus, it would leave this y on the left side of the equal sign with this negative 15 plus 6x. It's not lining up very nicely for us if we do that. So combination is probably not the method that we want to use. So let's go back and use substitution. So y equals this stuff, negative 2x plus 5. And we're going to take that stuff, we're going to substitute it into the other equation where the y is. So instead of negative 15 plus 6x equals negative 3 times y, we're going to do that negative 3 and then some parentheses, and then put that stuff that we know that y is that stuff, we're going to put that where y was in the other equation. And that's substitution. So from here, we've got an equation that just has one type of variable in it now, just x's, which is good. You can't solve an equation that has two or more different types of variables in it. You can only solve an equation that has one type of variable in it, like this here. And so that was our goal in using substitution. But we've got x's in more than one place, so we need to get those just to be in one place so that we can solve. So to do that, first let's simplify the right side. There's some math that can be done here, which is the distribution. And so we're going to just leave the left side by itself for a minute. we're going to distribute, which means multiply, a negative 3 times the negative 2x. Remember, the negative goes with the term to the right on each of those. Negative times negative makes positive, and 3 times 2 is 6 times x. And you don't have to write the positive there in front of the 6 if you choose not to. And then a negative 3 times a positive 5 makes a negative times a positive makes a negative. 3 times 5 makes 15. Okay, now we're going to try to collect our variables on one side of the equation. Right now we have x's on both sides. We want to get them all in one spot, and you can't just combine 6x and 6x like we've done in other circumstances, and the reason is that they're on opposite sides of the equal sign. You're only allowed to combine 6x with 6x if they were both already on the same side of the equal sign, in which case it would make 12x, but you can't do that here. So to get rid of the 6x on one of the sides, and it doesn't matter which one, we're going to subtract 6x to make 0, which means that that's no longer there, and we'll just be left with negative 15. But whatever you do to one side of an equal sign, you have to do to the other. And what ends up happening is that ends up making 0 too, and we're left with negative 15 on this side. So at this point, it might seem like maybe we made a mistake, but we didn't. We ended up with this funny looking result where we have a number equals itself. And that's true, right? Negative 15 does equal negative 15. And a true statement means that it has infinite solutions. It means that what these two equations would make on a graph is actually the same exact line, one right over the top of the other one. So just to remind what you may have learned in some of the other videos here, is that this type of scenario, when you get a true, when you've attempted to find a solution but you can't, you end up with no variables left at all, true means that you have a line on top of itself, and that means infinite solutions. So that's the answer to this problem. The other possibilities were that if you would have had a number like negative 15 equals some other number, like 7, for example, just making that up, if that statement is false, then that means that there is no solution. And so true and false mean either infinite or 0 solutions. And the only third option is if we had ended up with a value for x or a value for y, we would know that there was a point with xy coordinates and just one point, and that would be one solution. So the answer to this problem, though, is infinite. All right, thanks for watching another video from AskMath.com. Make sure to check out the rest of the videos.